Hi everyone, welcome to our webinar today, Calculus Webinar with Keanu Johnson, a senior instructor at mathematics at Spelman College. Keanu Johnson consistently strives to not only challenge students but to make mathematics relatable, engaging, and easy to understand. A native of New Orleans, she has received her bachelor's from Xavier University and master's from Emory University in Atlanta, Georgia. Keanu is committed to encouraging students to show them that every student can understand mathematics. This is a commitment that inspires her research and implementation of various pedagogical techniques to research today's students. Welcome everyone, and I'm going to turn the webinar over to Keanu Johnson.
Hi, thank you, Nancy, so much for that introduction. So again, my name is Keandra Johnson. I'm a senior instructor at Spelman College. And today we're going to talk about tools and some tips that I've used in my calculus courses to encourage student participation and to make sure that students come to class prepared. So in this webinar, a couple of things that I'm going to talk about. First, I'm going to start off with my pedagogical structure. And then I'll talk about a little bit more in depth what I mean by documenting and how that has helped in my calculus courses, how homework is very, very important in class preparation. We tend to think of homework as after class, but how do I incorporate it in pre-class activities? And what achieve tools that I've used this semester and a few previous semesters in helping me to achieve the goals that I want to achieve with my students. So first, my pedagogical structure. I always tell students that succeeding in any class starts with documenting. And if they document appropriately, then they can come to class and participate. And then that will assist them in completing their homework. If they have any questions that, please come to office hours or to get in groups and, create study sessions. And then we start the cycle all over again and go back to documenting. So let's discuss a little bit more in detail. What do I mean by documenting? So I define documenting as pre-class preparation. So it's just students taking notes, writing down definitions, theorems, the steps or processes used to solve the problem. And documenting is supposed to be completed before class. I always tell students, I do not want you to teach yourself, but I do want you to be prepared and to have a level or a knowledge of what we're covering that day in class. So oftentimes when you're in English classes or ethics classes, philosophy classes, there are readings, right, that the students are expected to read before coming to class, and that enhances the class discussion. So I use that same motivation in my calculus courses. So I want the students to read and take a select bit of notes so that they can be prepared for class discussion and problem sets. The documenting, previously I would check it periodically through quizzing. So I may at the start of class ask students, once they come in class and get settled, I'll ask students to take out a sheet of paper and they can use their notes and write down the product rule or the quotient rule that they documented the previous night, right? And so then I would just collect that quiz, and that was a way of me checking that they were documenting. And also from time to time, I would put guided notes on our LMS to assist students with documenting. Sometimes I found students would go to document and they didn't know exactly what to write down, right? You open a calculus book and it looks like a foreign language. And so I would include a few guided notes on our LMS to assist students in their documenting process. So what were some of the benefits I found when I really committed to requiring students to document? It enhanced in-class participation. So again, students had an idea of what we would be covering that day. So they came to class more eager to learn and to discuss. And they also, with this in-class participation, they also already had, I would say, a set of questions in their mind that they wanted to ask. And during lecture, I hope those questions were answered. But if not, then I would open up the class time a little bit later to give them an opportunity to go ahead and ask those questions. So if they document it, then it reduced my lecture time because I didn't have to use so much time writing definitions and theorems on the board and then allowing them to write them from the board, right? So I could spend that time, instead of writing, I could spend that time actually dissecting the definitions and the theorems. What does this mean? How will we use it? What are some applications that we can apply to this calculus concept? And then it became more real for the students. Another benefit is the class time. So once we were done with lecturing, then I was able to spend, or I am able to spend class time actually working out problems. And with that, that fostered active learning, because while we're working through the problems, we can do think, pair, share, right? We can do group problem sessions, or I can even do in-class activities. And I'll talk about those a little bit more in a second. So what are some challenges for the documenting? I mentioned that periodically I would do quizzing, but we can't do that every day. So it was difficult to reinforce. It was difficult to ensure that the students were actually documenting. Aside from me just getting that feel during class that yes, I can tell they documented because class participation, was great. So what about homework? How does homework foster class participation and student engagement? Well, I would give online homework. And in the online homework, we know that it's great because students can get that immediate feedback, whether the problems are right or wrong, and they don't have to do maybe a 10 problem set, give it to me, I grade it, and then return it, and then they see they got 3 problems wrong, right? So they were able to get that immediate feedback, whether the problems were right or wrong. But my concern was, were the students actually understanding the mathematical process involved in solving a problem? So, and unfortunately, I wasn't able, with the online homework as I was doing it previously, I wasn't able to determine that until maybe a test or a quiz, that the students were actually able to communicate precisely mathematical solutions and show all of their work efficiently. So what was my solution to that? I spontaneously collected homework. So I put a statement in my syllabus and I told students that although homework is submitted online, that the homework should be done neatly and efficiently, showing all of their work. And I would periodically collect homework. So I would just come to class and say, okay, guys, I'm collecting homework today. And that process should take about 5 minutes at most. So they just pull out their homework from their notebooks and then go ahead and turn it in. And the students knew that was the expectation. Also, periodically, since I was spontaneously collect homework, I started to do this one a little bit more frequently. In their online homework, I would assign 1 to 2 problems that they had to submit the next day. So that way I was able to see more frequently if they were able to communicate their mathematical solutions and not just can they get to the final answer result. And that helped significantly. Another way homework helped with class preparation and student engagement is at the start of class, maybe the first 5 minutes of class, I would allow students some time to submit one question from their homework that maybe no one can do. And then we would do the question together. And this allowed students to be more prepared and actively engaged in class lecture. It was like a warm up, right? So they felt secure in the previous content. So I made sure they were secure in their previous content before we moved on. Like we all know that calculus is very cumulative. So I want to ensure that the students know the previous content before moving on to the next content. And then if their foundation is secure, then they're more apt to participate and engage in class lecture. So again, what were some of the tools? I wanted to make sure that the students documented so that they were aware of what would be presented in the next class lecture, that they have their homework and that they would submit at least one problem. That helped me to ensure that they had a firm grasp on the previous content. And then the first 5 minutes of class or at the start of class, we would do like a warm up. So I think of this as, if you're going to the gym, if you're doing a yoga class, then you tend to do some breathing exercises at the start, right? Or if you're, I teach a Zumba class. So if you're teaching a Zumba class, there are about 1 to 2 songs at the start of class that we designate as warm-ups. And I want my calculus class to have that same active engagement. So the first 5 minutes we do a problem, the students can get that warm-up experience and then be ready to engage throughout the remaining time that we have together. So I mentioned that with my pedagogical structure, that one challenge with documenting was that it was difficult to reinforce. So when I started working with the Achieve product, well, I was always looking for ways to help me to the class participation. I think I had kind of mastered that, the homework, the office hours, but documenting, I was always looking for a way to ensure that students would document because I knew that it was a significant portion of what I call the success circle. And so working with Achieve, I was happy to see that they had two products that really helped me tremendously in achieving this documenting goal for my students. And one of them was Learning Curve. Learning Curve is basically a formative adaptive system where the students it'll test the students' knowledge of just basic foundational concepts. So it's asking more definition type things. And so I'm able to see, did the students, what I call document through the learning curve. You can put a target on the learning curve. So if the students get, say, 150 points, then they get credit. If the students get the problems wrong, it'll change the point values and give them more questions. If the students get the problems right, then they have to do fewer questions. So I love that. And it would provoke the students to go to the reading. So now instead of going to class blindly and just trying to get a feel of are they prepared, I was able to use the learning curve. So right before class, I would go in here and I would say, okay, great, 91% of my students have completed the learning curve. That's awesome. I know that they're ready to go into engage in class lecture. Another tool that I found very, very helpful was the guided learn and practice. And it was a little bit different from Learning Curve. It was more, here are some prerequisite problems that you would need in order to be successful in this next section. And then it would maybe give a few problems that were pretty basic from the section to see if the students can do it. Again, with these problems, I could see right before class if the students had done it or not, and that was a great tool. One of the big differences though with the guided learn and practice, it wasn't a target score. It's just did the student get the problems right or wrong? And they got points for getting it right or wrong. So then I could see what was the student's actual score on the guided learn and practice. And if you would like any additional information about either of these, please feel free to reach out to me and I can give you some additional information on how I use them in my calculus courses. So again, just to recap, so I was looking for something to enhance my pedagogical structure and in documenting and homework that helped significantly with class, making sure that the students were prepared and to increase the student engagement during class. And in that documenting and homework, the Achieve tools that I used were Learning Curve and Guided Learn and Practice. And both of them helped tremendously to ensure that the students were documenting and making sure that they were prepared for class lecture, which then increased their engagement during class. All right, so thank you for listening to the tips and tools that I've used. If you have any questions, I'm available to answer any.
Thank you very much, Keandra. I think Nancy may have had connectivity issues. Nancy, are you back? Okay, that's fine. This is Scott Guile. I'm one of the marketing managers that works with Achieve and other products at Macmillan, and we really appreciate you guys making some time for us today. We did get two questions in the course of the presentation, Keandra. They're both, I believe, aimed more at you than at any of us. So I'm going to read them aloud. Folks, you can continue to ask questions. Please use chat to ask questions if you have them. You are on mute, as you probably noticed, because when we have multiple participants, the ambient background noise can be we can't have it. It distracts. So we do want to hear from you though. So the first question is, how does think, pair, share work in Calc?
So for think, pair, share, what I would typically do is put a problem on the board. And my general motivation in class is I do the I, we, you approach, and I'll talk about that in a subsequent webinar, I do a problem for you, we do a problem together, and then now you can go and do a problem on your own. And when the students have an opportunity to do the problem on their own, sometimes I'll put a problem on the board and say, okay, start this problem. I'll maybe give them about 3 minutes, depending on the difficulty of the problem. I'm teaching Calculus 2 this semester, so of course the problems require a little bit more time. So I would give them a few minutes, and then I say, okay, you guys stop wherever you are. It doesn't matter if you're done. Stop wherever you are and turn to your neighbor. Sometimes I'll let them self-select, or I will select their partners for the day. And turn to your neighbor, give them your solution, and discuss with them what you think they did well, what you think they can improve upon. Is their solution precise and concise? Can you read it? And if you had to give them a grade up to this point, what would it be? And then once they have that dialogue with their partners, then they can complete the problem and finish the problem together. So that gives them an opportunity to think about how the other person did the problem versus how they did the problem, to share those opinions with each other, and then to complete the problem together.
Excellent. So I, we, you, I like that. I'd use that. I'd use that. I was a teacher myself, and I'd use that, but I haven't used. I had not heard of that. That's I think an interesting way to do it, to sort of step them into. Watch me. Let's do it together. Okay, now you're on your own.
Yes.
Second question that we got in here: what are the consequences for not having their work on days you collect it?
So it goes into their homework grade. So I partitioned their homework grade into 2 parts. So one part is achieve. I just go on achieve and I look at what's the percent. And then they have another homework grade that's based on the problems that they submit. And at the end of the semester, I take the average of those 2. Depending on how many things I've collected and how many achieve assignments I've given, I might do a 40-60 or a 70-30 split, to make sure that it's fair. But so basically when I grade those assignments, I just put them in my grade book as a separate grade, and then it goes into their homework average.
Thank you, Keandra. And I imagine there's any variety of things you could do for this. With our system, and frankly, I think with most systems, you could probably add an outside work column for something like that and not get within the same system. You certainly can do that for Achieve.
Yes.
You could also call it extra credit. I mean, I could imagine there's any variety of ways, but I think it's a great idea because it always exists, and it builds in accountability. Like you can't just Google this and find the answer. I need to see the work in your own hand.
Exactly. And
okay.
even if you could, and even for the problems that you can find the answer, I mean, the students are very resourceful. So there are those resources that would give them, the entire solution. They're limited, but for them to have to think through the problem and write down every single step, because even in the solutions, oftentimes steps are skipped and missed and, things like that. So I stress to them that I am looking for them to write down every single step. And sometimes I even require them to add words. So I tell them, pretend you're tutoring me, and you're writing up this solution as if you're tutoring me. What would you tell me in addition to doing the math? So I make it, a writing and mathematical solution.
Excellent, multidisciplinary sort of approach. We have one more question. Yeah, that came to me. Someone asked, what is learning curve? And I don't have the ability to, I would love to share, but I don't.
Can I share you?
So, Keandra, do you want to answer that? Because you're using it in a certain way, and I'd rather have the description come from you at this point.
Okay, so learning curve is, let's go here. Learning curve is, like I said, an adaptive formative system or assessment tool that's inside of Achieve. You can assign it. It is assignable. So as you can see here on this slide, I use it as a pre-class activity. I assign it points, and then I have a due date. And I can probably, let's see if I can exit and give a demonstration. So in learning curve, what it does is it asks students, I would say maybe diagnostic questions based on, I'm trying to stop sharing my screen so you can't see everything. Okay, stop sharing. So it's asking them questions based on the documenting that they did. So I'm gonna actually, while I'm talking, I'm gonna actually go ahead and pull up my Achieve account and go into one of my learning curves. And I think that'll probably be great to just show you an illustration of one. So what
Also, yeah. Also, if anybody's interested in seeing Learning Curve, we can make sure you set up with a demo on Learning Curve or any of the other aspects. And I'll give you my information to contact me when Keanda's done. Sorry to interrupt, Keanda.
Oh, no, that's fine. That's fine. So what I encourage students to do is to document first. So go to the book and make sure that they, I'm sorry, I saw a student's data at the bottom. To go to the book and make sure that they write down the definitions and theorems, and then that would help them complete their learning curve significantly faster. So I have here the target score, you can set it, and then I have the 2 topics. And if you see over here, the 2 topics for this one will be integration by parts. And there's another one at the bottom. I can't exactly show it because you'll be able to see one of.
What might be better is click preview as student. There you go. Begin activity. That way we're not going to see any student data.
Thank you, Scott. So yes, so here's the target score, and here are the 2 topics. These are optional. You can edit these as well. You can omit one of them if you want to make it more precise. So here the student has 200 points. That's their target score. So it's just asking them more definition type questions. So I know coming into class, yes, they know what I'm going to talk about. So if I click here 0 and I say, okay, I want to go ahead and submit this answer, then it's, sorry, I didn't get any points. You can get a hint. You can read the ebook. So even if the students didn't document prior, it's like it forces them to go and to document. So we can say, okay, let's do, sorry. So they can get a hint and you can show the answer, or they can actually just move on to the next question.
And they can get it right up to 3 guesses, but it's a decreasing number of points they will earn. They'll never get points taken away. This was built as a formative piece. So the students simply earn points to fill that bar. They fill that bar, they complete the assignment. They can't get an A, they can't get an F. They can simply complete it. And the more the student knows, the more quickly they'll complete it. The less the student knows, the more work they'll have to do, and that's sort of by design. And it really great pre-class formative thing because it builds that foundation, and it cannot be punitive. And as you can see, even when they get it wrong, they get some feedback. Students in particular have told us really like that I get feedback and not just I'm wrong. So there's a lot of this is probably the most popular student piece of media we have ever as a company done. It's like 90% approval rating from students over the course of, at this point, over a decade. It didn't look like this a decade ago. We continue to work on it, but this is something we've been offering in various forms for about a decade. And as you can see, there's various different questions. Sometimes there'll be an image embedded in the questions. The questions do get harder as they get them right. So if they're getting them right, the next question from that topic will be harder, aka it will have more points associated with it. And at the halfway point, the section, the subsection they're doing most poorly in, the questions will come more from that area. So those are the 2 sort of adaptivity pieces behind this. You've got the difficulty adaptivity, and then at the halfway point, once we have some baseline data, then it gives them different, it gives them more material from where they're doing worse. And I think that's probably enough on learning curve. Let me just another quick check for, okay, that seems to be the last question. Nancy, I think you're back if you want to wrap it up.
Yes, well, thank you everyone for joining us today. Thank you, Keandra, for doing this webinar and showing us how you use Achieve in your classroom. If anybody is interested in more information on Achieve or would like to, get a demo of Achieve, then you can contact me, nancy.bradshaw nancy.bradshaw@macmillan.com. nancy.bradshaw@macmillan.com. And I'll make sure that you get to review Achieve or answer any questions that you have. Thanks everyone for joining. Have a great day. We have another webinar coming up at 2 o'clock talking about engagement in the classroom.
Thank
Hope
you,
you can join us
Keanu.
then.
Thanks, guys.
Thank you.
Thank you.